For these three functions, we're trying to find if there are any vertical asymptotes and actually see, on what values these functions are continuous. Well, I know a vertical asymptote happens if you have a number that's not equal to 0 over 0. So what I'm really looking for is the denominator. I'm going to take each one of these and I'm going to set the denominator equal to 0. So for this problem, I'm going to say x squared minus 25 equals 0. And I'm going to factor to solve. So I have x plus 5 and x minus 5 equals 0. So x equals negative 5 and 5. Now right now I know where my function is not going to be continuous. It's not continuous when x equals negative 5, and it's not continuous at x equals 5. So I know it's continuous everywhere else, and everywhere else starts at negative infinity. It's going to go to negative 5. We're going to restart at negative 5, go to 5, and then restart at 5, go to infinity. So I have two discontinuities, one at negative 5 and one at 5. If I want to know what kind they are, I'm going to look at the numerator. If the numerator is 0, I have 0 over 0, and that's removable. If it's not 0, I have a number that's not 0 over 0, and it's an asymptote. So if I take x equals negative 5 and plug it into the numerator, negative 5 minus 5 is negative 10. That would be a negative 10 over 0, so that is an asymptote. So I'm going to say x equals negative 5 is an asymptote, and it's a vertical. If I take 5 and plug it in, 5 minus 5 is 0, so that gives me 0 over 0, and x equals 5 is a removable discontinuity. Okay, so I'm going to do it again. I care about the denominator. So I'm going to say x minus 2 cubed equals 0. Well, if x minus 2 cubed is 0, then x minus 2 has to be 0, because 0 cubed is 0. Or you could say I'm just going to take the cube root of both sides, but x minus 2 equals 0, which means x equals 2 is where the bad thing is, bad spot. So we have a bracket of some kind at 2. It's our only break, so I'm going to say that this function is continuous from negative infinity to 2, and then it's continuous from 2 to infinity after that. Now I want to know what kind of discontinuity is, so I'm going to take the 2 and plug it in to the numerator, except you can't. The numerator is always 4. So it's going to be a number that's not 0 over 0, so x equals 2 is a vertical asymptote. Okay, one more. I look at the denominator. X squared plus 4 equals 0, and I see right away that we have a problem. But if you don't see it, just start solving. Okay, you can't factor this, but I can move the 4 over. So x squared equals negative 4, and you should see the problem now. You're squaring something and getting a negative, but if you don't see it, you'll see it on the next step. Take the square root of both sides, and this is plus or minus the square root of a negative 4, and we have an imaginary number. What that means is this denominator is never equal to 0. And you should be able to tell that just by looking, because you're squaring something which the smallest that can get is 0 if x is 0, and then you're adding 4. If you square a positive and add 4, you get a positive. If you square a negative and add 4, you get a positive. So this graph is actually continuous always. So it's continuous from negative infinity to infinity. So we have no asymptotes and we have no removable discontinuities.